Hello everyone, my name is Antonin Cheymol and I will present you today a research conducted at the University of Tokyo named Increasing the Perceived Speed of Dynamic Handheld Shape Displays through Visuo-Haptic Illusions. So, in virtual reality, current devices enable to provide satisfying visual and audio immersive experiences. However, more solutions are still required to render authentic and immersive tactile experiences. Various devices have been developed to tackle this limitation. Among them, dynamic shape displays that can adapt their shape dynamically have the capability to render forces, shape, and also dynamic touch sensations, which allows them to render realistic active tactile sensations or to convey diverse information using the sense of touch. In particular, handheld displays have the advantage of enabling greater freedom of movement and location, which allows users to experience various haptic sensations from virtual objects at different locations. In addition, they can provide skin contact to the entire palm and fingers, providing a natural tactile grasping sensation. However, handheld devices are naturally required to be sufficiently small and light to be grasped and carried by its user. In this study, we focus on improving the user's experience of dynamic handheld shape displays by directly influencing their perception of the tactile sensation. To do so, we use a technique called Visuo-Haptic illusions. Visuo-Haptic illusion is a phenomenon wherein haptic perception is modified by visual feedback owing to the interaction of sensory information in cognitive processes. For example, previous research have successfully used Visuo-Haptic illusions to modify the tactile perception of shape, size, and softness. Visuo-Haptic illusions also have been used successfully in previous research to increase the speed perception of dynamic shape displays. However, this research was conducted with a tactile contact area restricted to the fingertip, and investigated only one technique and actuation speed, calling for further Visuo-Haptic illusion research addressing the speed limitation. In our study, we present two Visuo-Haptic illusion approaches to modify the perceived actuation speed of dynamic handheld shape displays. Each are impacting the visual actuation speed by modifying one of the two components of speed, either the visual travel distance or the visual travel time. The latter one can in turn be subdivided into two techniques, as this approach can be implemented in two different ways, either by delaying the start of the visual actuation or by advancing its end. The distance modification approach increases the travel distance ratio between the visual and the haptic activation. Let's see it one more time. Then, the time modification approach decreases the visual actuation duration compared to the haptic one. As I mentioned earlier, this approach can be subdivided into two techniques as it can be implemented in two ways, either by delaying the start of the visual actuation or by advancing its end. Let's see it one more time. First, the delayed start technique and the advanced end technique. So, in order to evaluate the potential of our illusions to influence the speed perception of dynamic handheld shape displays, we conducted two user studies. The first one aimed at extracting for each technique their detection threshold, which is the point above which a visual haptic mismatch will be detected by the participant. Then, the purpose of the second study was to evaluate whether or not each technique increased the speed perception when presented under the specific detection threshold. In these studies, we evaluated each of the three presented techniques: distance modification, time modification with delayed start, and time modification with advanced end. We also decided to study the illusion under two distinct actuation speeds, in order to get further insight of the potential influence of the action speed on the illusion result. In both studies, participants were presented to the previously presented Visuo-Haptic illusions using the following dynamic handheld shape display. This device contains sets of pins which could elevate in order to present haptically a movement sensation to participants. The device was replicated visually in VR through a head-mounted display in order to present the user to mismatching visual elevations. In the first study, which intended to extract each condition's detection threshold, we conducted an experiment during which participants experienced various elevations presenting a Visuo-Haptic illusion. In other words, a mismatch between the visual and the haptic information. Each speed and technique conditions were tested under 5 Visuo-Haptic mismatches intensities conditions. After each elevation, participants were asked whether or not they felt a mismatch and how much they were confident about their answer. The results of the first study are shown on the present graphs, and shows for each condition the average detection ratio of the illusion. Under each speed condition, the detection thresholds were higher for the distance modification approach than with both time modification techniques. The results of each time modification techniques were relatively similar, but for each one, the slow speed condition seemed to be easier to detect, which could be explained by the fact that for each different speed condition, the duration mismatch was identical in percentage, thus inducing a longer mismatch in terms of absolute time for slower elevation. These results, as well as questionnaire results, lead to think that in terms of speed perception, people are more sensitive to the mismatch induced by the speed discrepancy, in our case, timing and length mismatch, than to the speed mismatch itself. Then, in the second study, we investigated the impact of the proposed Visuo-Haptic illusions on the participant's speed perception when presented under the detection threshold found in the first study. In other words, when they are unnoticeable. Each sample consisted in presenting two identical physical elevations, one presenting a Visuo-Haptic illusion under the detection threshold, the other without any illusion, and then to ask to the participants which one he felt was the faster. The present graphs show the result of the second study. Each chart represents the ratio of time the elevation presenting with an illusion was declared to be faster. The ratio at which each elevation presenting illusions were found to be faster was above 50% for each condition, meaning that even when presented under detection threshold, the illusion tended to increase the speed perception. Also, as expected, illusions presented with higher Visuo-Haptic mismatches tend to have more impact on the speed perception. You can find here a summary of our main findings and the limitations and future works remaining to explore. Thank you for your attention, and please refer to our paper for further information about this research.